previous slide, we showed how we can convert the base in an exponential function. So why would we want to do that? And the answer to that is that some bases are more convenient than others as far as mathematical manipulations are concerned. And in calculus, the preferred base is an irrational number which is denoted by e. And using e as our base can be very convenient for reasons that we'll look at now. So e is a number which goes to many decimal places, and here we have just shown it to 5 decimal places. And when we have a base of e, this is referred to as the natural exponential function. And some examples are given below. Okay, y is e raised to the power of x, right? Y equals e raised to the power of t, or y equals a times e raised to the power of r times t. Okay, so one of the reasons that we're going to, or that we choose e, is that the function e raised to the power of t possesses the property of being its own derivative. Having a look now at some of the rules for differentiating exponents, what we can see is that if y equals e raised to the power of t, and we want to find the derivative of y with respect to t, then the derivative is the same as e raised to the power of t. And obviously here we've labeled the variable t, but if we'd had x here, then the derivative would have been e to the power of x. So what if our variable t is replaced by some function of t? So let's say we are working with this exponential function where we've got a times e raised to the power of r times t, where a and r are constants. And what we're going to use here is the chain rule in order to find the derivative of y with respect to t. So if we write this function as y equals a times e to the power of w, given that we have let w equal rt, and we apply the chain rule to find the derivative of y with respect to t, all right, what we need to do is find the derivative of y with respect to w, all right, and then the derivative of w with respect to t. And the derivative of y with respect to w, we are working with this function here, and we know that this function, its derivative will be equal to a times e to the power of w. Okay, that's this part of the chain rule. All right, and then finding the derivative of w with respect to t, we have to work with this function, and we would end up with r. And then if we substitute back into w, we would end up with our final answer for the derivative as follows. If we look at this function and see what happens as m approaches infinity, we can get an idea. We can start to get an idea of how we can use this in our economic analysis. So we have our function. Okay, we've got m here, and as m increases in value, here we show it going from 1 to 2 to 3 to 4, what we can see is that the value, okay, for the function also increases. Now as m approaches infinity, so as m is increased indefinitely, what we see is that f of m, okay, as m approaches infinity, converges to the number E. Okay, so it converges to this value here. Calculation that we worked through on the previous slide becomes very important now when we look at the process of interest compounding. So let's start by understanding what we mean by interest compounding. So if we have this example and we invest 100 Rand at an interest rate of 5% per annum per year, the value of the investment after 1 year, okay, so the value of the investment after 1 year is going to be 100 Rand plus 5% of 100 Rand, which is 5 Rand, and we get a value of 105 Rand. So our formula for calculating that 105 would be as follows. The value of the investment after 1 year would be equal to the value of the initial investment, okay, at the beginning of the period, multiplied by 1 plus 0.05, which would give us 105 Rand. Okay, and stated in a more general way, the value of the investment after 1 year is the value of the initial investment, okay, in period 0, at the start of the period, multiplied by 1 plus R, R being the interest rate. All right, if we then decide to reinvest in the following year, we want to work out the value of our investment at the end of year 2. All right, and the value of our investment at the end of year 2 would be the investment at the beginning of the year, which would now be 105, okay, multiplied by 1 plus the interest rate, okay, which is 5%, and we would get a value of 110 Rand and 25 cents at the end of year 2. So another way of setting out this calculation would be as follows. The value of our investment at the end of year 2 is the value of our investment at the beginning of the time period. So when we first started investing, okay, when it was V0, it was 100. And then we need to multiply that initial investment by 1 plus 0.05 and again by 1 plus 0.05 because we've now invested it for 2 years. Okay, so stating that more formally, we can obviously rewrite what's in these brackets, given that they're identical, as squared. Okay, because we are investing for 2 years. So the value of the investment at the end of 2 years would be the value of the original investment, okay, which was 100, 1 plus the annual interest rate and squared. Okay. If we wanted to work out the value of the investment after 10 years, okay, it would be a similar formula, except of course now we are working with 10 years as opposed to 2. And similarly, after T years, with an original investment of V0, okay, compounding the interest once a year, we could work out the value of our investment after T years using this formula here. Looking at this slide now, we're going to change things a little bit, and instead of adding the interest every year, we want to add it every 6 months. So how will that change our calculation? After the first 6 months, we are going to add interest to our investment. So we are still working with a 5% interest rate, but this is the annual interest rate. So if we are adding interest every 6 months, that means that we are going to be adding interest twice during the year. Okay, 12 divided by 6. And accordingly, we need to divide the annual interest rate of 5% by 2, okay? Because we're going to be calculating interest after the first 6 months. So that is how our formula would change. We would be able to work out the value of our investment after half a year, and we would take the initial value of the investment, and this formula is the same, other than we have now divided R by 2. Okay, and that would be our answer, the value of our investment after 6 months. But we are still investing for a year. It's just that interest is being added every 6 months. So we still want to know the value after the first year. Okay, we want to know the value after the first year. And after the first 6 months, our value was 102 Rand and 50 cents, as we calculated here. And then we will also be adding interest for the second half of the year. Okay, so again, for the second part of the year, for the next 6 months, we have to take the annual interest rate, dividing it by 2, and if we multiply this sum, or this value, by this value here, we will end up with a investment, or with a value for our investment of 105 Rand. Okay, and if we look at the formula, all right, what we have effectively done is we have taken our initial investment of 100 Rand, and we've multiplied it twice by what we have in this bracket. Okay, so we can rewrite this more efficiently as follows. Okay, what's in the bracket? Squared. All right, and if we want a more general formula, the value of our investment at the end of year 1, when interest is added every 6 months, is the value of the original investment times by 1 plus the annual interest rate divided by 2, and then we have to square that. In this example now, we are compounding every 3 months, and that means that we are going to be adding interest 4 times during the year. Okay, given that there are 12 months in a year and we are compounding every 3 months, that means that interest gets added 4 times throughout the year. So if we want to work out the value of our investment at the end of year 1, we need to take the value of the original investment and multiply it by 1 plus the annual interest rate divided by 4. Okay, because we are adding interest 4 times a year, which is every 3 months. Okay, and we would need to raise what's in this bracket to the power of 4, because we would effectively be multiplying V0 by what's in this bracket 4 times. Okay, so it's obviously far more efficient to write it out, to have the bracket raised to the power of 4. Okay, so using our example, our original investment is 100 Rand. 1 plus the annual interest rate is 5%. All right, we're dividing it by 4 because we are adding interest every 3 months, 4 times a year, and we need to raise this bracket to the power of 4. Okay, and that will be the value of our investment after 1 year if we compound every 3 months. Okay, and what we can see from this example is that the more often we compound within a year, the higher the value of the investment after 1 year. Okay, and we can set out a general formula for compounding n times a year after 1 year. Okay, the value of our investment the way we would work out this value is by taking our original investment and times it by 1 plus the annual interest rate divided by the number of times we are compounding during that year, and then this bracket is obviously raised to the power of n.